So now we've been talking about serial, specifically UART, talking about serial protocols and in general how they work. So now we're going to talk about how you actually use that on an Arduino. Arduino serial communication. So UART protocol is used over the USB cable. That's not how it used to be. It used to be there was an RS-232. When I say used to be, back in the old days, when you use UART, you always use it together with an RS-232 cable, or commonly use it with that type of cable. That's not what we're using here. We're taking UART and we're transmitting it over the USB cable, which is the Arduino's connection to the host computer. So it's being transmitted over the USB. And what we're using it for, we can use it for several things. You can use it for interfacing with your machine, actually, with your Arduino. For one reason we're using it is for debugging. So it can be also used for debugging. So basically, if you have some debugging statement that you want to print out during the execution of the code to say something about the status of the code, you can change your code, put in effectively a print statement, which I'll show you in a second. You can put a print statement in there and it'll be printed to the screen of the host, okay, using the serial monitor. So what happens is you can start the serial monitor on your host, and then when you do one of these print statements, the text will appear in the serial monitor. But you can use serial interface for lots of different things, all kinds of communication from the host to the Arduino at runtime. You can use a serial interface. So you initialize the interface by invoking this command, serial.begin. You invoke that inside your sketch. Typically, that's going to be inside the setup part, because you usually want to initialize the serial one time only right at the beginning when it starts running. So you'd put that in the setup function of your sketch. Now, begin can take one argument or two arguments. You can just say serial.begin with the speed, or it can take the speed and the configuration. The speed is the baud rate. So you give it a baud rate, 9600 baud is typical. You can give it what you want. Just make sure that the baud rate that you use is synchronized, is the same as the baud rate used on the receiving end. So remember, there's two things communicating here. There's the Arduino and there's the host. So if on the Arduino side, you set the baud rate to 9600 baud, then on the host, the baud rate, the host meaning the serial monitor, which is the program running on the host, it has to have a baud rate set at the same speed. Okay. Now, the default is 9600 baud for us, so we're going to just stick with 9600 baud. Then you don't have to change any settings of the serial monitor. You just start the serial monitor, and bam, it's running at 9600 baud, and it'll work. If you do decide, oh, look, I want faster communications, and you go with a higher baud rate, something like that, then you have to change that in the serial monitor as well, or the serial monitor won't read the data. So the config argument, if you decide to use it, is the configuration of the serial communication. So all the information about, or most of the information about the serial communication that has to be known between the transmitter and receiver. Specifically, it says the data bits, the number of data bits, typically 8. 8 is the default if you don't set the configuration, but you can change that and make it 7 or something like that. The parity bit, so are you using a parity bit or not? Yes or no. And you can make it even or odd parity, inverting the parity, but you set if you're going to use parity bit or not. Also, the number of stop bits. You can use 1 stop bit or 2 stop bits, and you can set that in the configuration as well. So an example is you could just type serial.begin 9600. That's typical. It just gives the speed as an argument and uses the default configuration, which is 8 data bits, no parity bit, 1 stop bit. Or you can specify the configuration. So here we say 9600 baud is the speed, but we use serial 8 and 1. So that specifies 8. That 8 there is for the number of data bits. The N is for no parity. And the 1 is for the number of stop bits, 1 stop bit or 2. You usually call serial.begin inside the setup function because you usually only need to do it once. So when you're sending data over serial, you've got to invoke, in order to receive it, you've got to invoke a program on the host to receive it. Now, the built-in program with the Arduino IDE is going to be the serial monitor. Now, just as a note, you don't have to technically use the serial monitor. You can use any program that can receive serial data. So there are lots of terminal emulators that you can use that will receive serial data, like PuTTY or something that I use, but you can use a lot. But we're going to be using the serial monitor. So you invoke the serial monitor from the IDE, and it opens up a window that looks like this. Now, there's text running in there. I'll explain that in a second. Now, in order to print something, to send data, send some text from the Arduino to the host, to the serial monitor running on the host, you got to call a function, either set serial.print or serial.println. And that prints text in the serial monitor on the host. Now, serial.print just sends the text, so you can put in quotes hello, like I have there. Serial.print hello, and it sends the word hello. Or you can put serial.println, and that prints the text, and it also prints a carriage return. I chose, in this case, serial.print hello, so there's no carriage return. So if I put that in the loop, my loop is just serial.print hello, I upload that to the Arduino and I run it. And then it runs as soon as it's uploaded, it starts running. Then I start the serial monitor. When I start the serial monitor, this is what I see in the monitor, the word hello over and over and over again. That's because it's in the loop, and the loop just runs forever. So you'll just see the word hello repeated forever. And notice that there's no carriage return, right? Just hello, 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 all on one gigantic line. Because I didn't use println, I used print. So that's how you send text over serial, with the print function or the println function. And strings are converted, strings like hello, are converted to ASCII and sent over UART. So remember, ASCII is the way we represent characters. So the ASCII table, you can Google this, it's a table that maps every character, visible characters and invisible characters, to an 8-bit number. And so we don't see that. When we do a print, we don't see the ASCII. But that's going on behind the scenes. The data, the words hello, the word hello is 5 characters, H-E-L-L-O. So that's converted into 8 different bytes, right? One ASCII code byte for each character, and those 8 bytes are transmitted by serial. And then on the receiving end, the serial monitor, it receives each of these 5 bytes, and it interprets it as ASCII. So everything it receives a number. It doesn't print the number that it receives. It says, oh, that number must be an ASCII value. It looks in the ASCII table and converts it to the corresponding ASCII code, and you see the text. So we don't see the ASCII here. Now, it interprets all the bytes that it receives as ASCII. Now, let's say you want to send data. You don't want to send text. A string, you just want to send some raw data. You want to send a number, like the number 42, right? You want to send that number. Instead of using print, serial.print, you use serial.write. And then in parentheses, you just pass the number, the value that you want to send, and it'll send that number, 42. Now, take a look at the serial monitor there, and what you see is an asterisk, right, repeated over and over. The reason for that is because the number 42 is being sent to the serial monitor, but the serial monitor is interpreting that as an ASCII value. So it's taken the number 42, looking up in its ASCII table what character that is, and it turns out that the number 42 corresponds to an asterisk. So that's what it prints. So it doesn't print the 42. It looks it up and it prints the character that 42 corresponds to, which is an asterisk, which is what we're seeing. That's what the serial monitor does. Presumably, if you're sending data over serial, you might not use a serial monitor. Remember that you can use serial communications with anything, right? With maybe you got another processor which also has serial, right? Has UART. And so you might not want to interpret the data. That 42 might not be meant as a character, as an asterisk character, right? You just want to interpret it as raw data. You could do that, but the serial monitor always interprets everything as an ASCII character and prints it that way. Thank you.